Today we're going to talk about triangles and when triangles are congruent. So what does it mean to be congruent? Well, when we talk about congruence, we're talking about two geometric figures that have the exact same size and shape. So for example, these are all congruent figures because they have the same size and shape, although they may be oriented differently. However, these, although all being triangles, are not congruent to each other because they are either different sizes, so the first and second triangle, although they have the same shape, they're different sizes, and that third triangle is a different shape, although it's a triangle as well. So in a congruent figure, all corresponding parts are the same. That means any of the sides, they have corresponding parts that are the same, or any of the angles, they have corresponding angles that are the same. Now we can write what we call congruent statements, and when you're writing congruent statements, you're always going to list corresponding parts in the same order. Here's an example. We have two triangles here, ABC and DEF. Now everything has been marked with either tick marks or arc marks to indicate which corresponding parts are the same as the other. But as we write the congruent statement, we want to make sure that we write them in the same order. So A, angle A there, is congruent to angle F, B with E, and C with D. So if we want to write triangle ABC is congruent to, we'd have to write triangle FED. It doesn't have to be in the order ABC. For example, if you said triangle BCA, you just want to make sure that you correspondingly write the other triangle's vertices in the correct corresponding order as well. So if you said BCA, you would say that's congruent to triangle EDF. So being able to see the congruent statement actually tells you a lot of information if you didn't have the diagram. For example, if you just looked at the congruent statements, you would see the corresponding angles. So angle A is congruent to angle F, angle B with angle E, and angle C congruent to angle D. Same with the sides. You can actually see the corresponding sides that are congruent to one another. So AB is congruent to FE, BC is congruent to ED, and AC is congruent to FD. Let's take a look at example 1. Write a congruent statement for the triangles. Identify all pairs of congruent corresponding parts. So seeing how everything is marked for us here in our diagram, all we have to do is pair up the corresponding parts. So we see here that J corresponds to T, we see that K corresponds to S, and L corresponds to R. So if we were to write triangle JKL is congruent to, we would have to match it up, so J with T, K with S, and L with R. So this would be triangle JKL is congruent to triangle TSR. After writing the congruent statement, it said to identify all pairs of congruent corresponding parts, and so we've already said this out loud, but angle J is congruent to angle T, K with S, and L with R. Now we can do the same with the corresponding sides, so JK is congruent to TS, KL congruent to SR, and LJ congruent to RT. Alright, let's take a look at example 2. In the diagram, DEFG is congruent to SPQR. Now note that in the diagram, there's no indication which corresponding parts are congruent to each other. However, because we have the congruent statement, we can gather that information from there. So we see here that DE must correspond with SP, EF with PQ, FG with QR, and that might be somewhere we want to start. So to find the value of x, we know FG is equal to 12 and QR is equal to 2x minus 4. So setting that equal to each other, we have 12 equals 2x minus 4, and we can solve that and get 16 equals 2x, so x equals 8. Now we still need to find the value of y. Now we do have an angle measure here that has an expression in terms of y. It says 6y plus x. That's angle Q. Now we have to determine what's the corresponding angle to angle Q. So we look back at the congruence statement, and we see that angle Q is congruent to angle F. So we can start there. So that 6y plus x has to equal 68. And because we just found x is equal to 8, we can substitute that in and solve. So subtract 8 from both sides, divide both sides by 6, and we get y equals 10. Take a look at example 3. If you divide the wall into orange and blue sections along JK, will the sections of the wall be the same size and shape? Now, to take a look at this, we need to determine whether or not we can find that all the sides of one will be corresponding and congruent to all the sides of the other, and same with the angles. Now, taking a look at the diagram, we see here that we are told that AJ corresponds to CK, DK corresponds with BJ, and AD corresponds to CB. Now, we still need to determine whether or not all the angles have corresponding parts that are congruent. Now we can see here that on the far edges of the walls, in the corners, we have 90-degree angles. So we see here that angle A corresponds to angle C, angle D corresponds to angle B. Now what about angles 1, 2, 3, and 4? Well, if you'll remember, when we talked about angles and transversals, we talked about if you have lines that are parallel to each other, and you have a transversal cutting through both of them, we have some information about alternate interior angles. So we know alternate interior angles are going to be congruent here. That means that angle 1 must be congruent to angle 4, and angle 2 must be congruent to angle 3. All right, so this just says everything that we've just explained. So, based on that, we've shown that every single side and every single angle corresponds to every single side and every single angle of the other. So yes, we can say that those two sections will be congruent, or in other words, will be the same size and shape. Okay, we have a theorem to go over called the third angles theorem. This says that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. Now this really just comes from the fact that we know that every single triangle, the interior angles have to sum to 180 degrees. So if you know two of the angles in a triangle, you know what the third one has to be. Now if you have two triangles, and you know that two of the angles correspond to two of the angles in the other, then you know that that third angle also must be congruent. So in this case, if angle A is congruent to angle D, and angle B is congruent to angle E, then angle C is congruent to angle F. Let's go ahead and apply this to example 4. Find the measure of angle BDC. Now, if it is helpful for you, you can absolutely redraw these triangles so that they don't overlap. Sometimes that can be helpful so that you don't mix up angles or mix up your labeling. Now here we see that angle A is congruent to angle B, okay? And we also see that angle ADC is congruent to angle BCD. So since we have two pairs of angles that are congruent to each other, then by the third angles theorem, we know that angle ACD is congruent to angle BDC. So by the triangle sum theorem, the measure of angle ACD is equal to 180 minus the 45 minus the 30, which is equal to 105. Now, because we know the measure of angle ACD is congruent to the measure of angle BDC, we know that angle BDC must also be 105 degrees. And that's applying the third angles theorem. All right, the last thing we're going to go over are some properties of congruent triangles. First is what we call the reflexive property of congruent triangles. So down below here, we have three triangles, ABC, DEF, JKL. So for any triangle, triangle ABC must be congruent to triangle ABC. So any triangle is congruent to itself. That's called the reflexive property. Next, we have the symmetric property, which says that if triangle ABC is congruent to triangle DEF, then triangle DEF must also be congruent to triangle ABC. So if one is congruent to the other, that other must also be congruent to the first. The last one is what we call the transitive property of congruent triangles. This says if triangle ABC is congruent to triangle DEF, and you know that triangle DEF is congruent to triangle JKL, then you can say that triangle ABC must be congruent to triangle JKL. So the transitive property says if one triangle is congruent to the second, and the second is congruent to the third, then the first must be congruent to the third.